Hello everyone and welcome back. So this is another theorem on Laplace transformation, which is sometimes called multiplication by power t. Now you see, we know that Laplace transformation of f of t is what? F of s. But here with f of t, we have another term which is t to the power n. So n can be 1, 2, 3, anything, any power, any natural number. Now look at the right hand side. So depending on this particular n, we have to write minus 1 to the power n. It will come like this, minus 1 to the power n. So if n is an odd number, so minus will be there. And if n is an even number, then this will become what? Positive. Then d to the power n by ds to the power n, f of s. So what is f of s? F of s is Laplace transformation of the function what? F of t. Okay. So let us do the proof. So we have Laplace transformation of f of t is f of s, and then what is f of s? Is 0 to infinity e to the power minus st f of t dt. Okay, now if we differentiate, suppose d by ds f of s, then 0 to infinity. So what will happen? We are differentiating with respect to s. So here these two are constant then, because t and s are independent. So we have to differentiate only this part only. Okay, so this is also called differentiation under integration, because integration is already there, right? Or you can write like this also, dds, then e to the power minus st f of t dt. Then in the next line we can write like this, del by del s. Now why delta? Because s and t are what? They are independent. So d and del will be same here because they are independent. So total differential and partial differential will be same. E to the power minus st, because here s is there, no? So we have to take del del s with this particular term. And f of t dt we can write separately because this is completely on t. Okay. Now after differentiating, what will come? So if we differentiate this, what will come? 1 minus sign will come out, right? 0 to infinity. It will be minus t into e to the power minus st, then f of t dt. So now what we will do, this minus sign, right? This minus sign will bring on the left hand side. So it will be minus d by ds f of s 0 to infinity t e to the power minus st, or this still let us write with this function t f of t dt. Okay. Now see this minus sign, we can write minus 1 to the power n, then d by ds f of s. Now this particular integration look like what? 0 to infinity e to the power minus st. This is f of t dt. So this is nothing but Laplace transformation of f of t. But here f of t is what? T into f of t, t into f of t. So what we are getting, therefore Laplace transformation of t into f of t is equals to minus 1 to the power 1 d by ds, then f of s. So this we got after differentiating once. Now if we differentiate it twice, then what will get? This will become t square, then f of t. Right side will get minus 1 to the power what? 2. This will become d square by ds square, because if we differentiate it twice, right? So similarly, if we differentiate n times, then what will get? T to the power n f of t, and on the right hand side we will get minus 1 to the power n d to the power n by d s to the power n 1 f of. It's a very simple proof. Okay, after differentiating once, so similarly you can write up to nth. So this is the formula or theorem. Now applying this particular theorem or the rule, let us do some example. Like you see this function here, n is how much? Here n equals to how much? 2. What is our f of t? Our f of t is cos at. So first we have to find Laplace transformation of cos at. So this is nothing but s divided by s square plus a square. Okay, then we have Laplace transformation of t square f of t is equals to minus 1 to the power 2 d square by ds square, and then what? F of s, right? So this implies Laplace transformation of t square. So our f of t here is cos at, then minus 1 to the power 2 is 1, then d square by ds square f of s. So this is our f of s. So it's s divided by what? S square plus a square. So what to do? We have to differentiate it twice because it's d square, right? So let us differentiate it twice. So if we differentiate it once, then what we'll get after differentiating? U by v form. So let us keep one dds outside. Then s square plus a square into 1 minus s into twice s divided by s square plus a square whole square. So this we get after differentiating once. Okay. So what will get then? D by ds a square minus s square divided by, we get s square plus a square whole square. Now we have to divide it, differentiate it again because still one ddx left out. So again in the form of u, we just differentiate. So first v into differentiation of this is minus twice s, then minus a square minus s square. If we differentiate this, what will get? 2 into s square plus a square into then twice s. Okay, whole thing divided by s square plus a square. Now it will become whole to the power what? 4. Whole to the power 4. So let us simplify this and see what will come. So how much you will get? Get something common from there. Minus twice s square plus. Okay, see, we can cancel one s square plus a square, no? From both numerator and denominator. You will get minus twice s square plus a square. Then there is a minus, you can write plus twice s into s square minus a square. Okay, whole thing divided by s square plus a square. Now it is cube because one term cancel out. Now here 2 minus twice s, this term will cancel out. Okay, these two term will cancel out. So what will get? Minus 2s square, again minus 2s square. So it will be minus 4 a square s divided by s square plus a square. Okay, it's a very simple sum. Just correctly we have to differentiate twice. Then the same way you try this one. Okay, this we will get same process, but just in place of cos, I have written here what? Sine. Now let us take another problem. For this particular problem, n equals to 3, and what is our f of t? F of t is e to the power minus at. So first we have to find the Laplace transformation of this one. So this will be 1 divided by s plus a. So this is our f of s. So we have Laplace transformation of e cube e to the power minus at. So this will be, since power is 3, then d cube by ds cube f of s. Okay, f of s. So here minus will remain because the power is odd. So minus d cube by ds cube. And what is our f of s? F of s is 1 by s plus. So we have to differentiate it twice. If we differentiate it once, then what will get? This is of the form 1 by x. It's minus 1 by x square. So minus minus plus. Let us differentiate it again. If we differentiate it again, then we will get minus 2 divided by s plus a whole cube. Minus 2 outside. So finally, when we differentiate it again, it will be minus 3 divided by s plus a whole to the power 4. The final answer is 6 divided by s plus a whole to the power 4. Okay. So you see the problems are very simple. Okay, but we have to apply the formula correctly so that you get a correct answer. Okay. So what this particular problem is, s divided by, right, s square plus a square. So when we differentiate it once, so s square plus a square whole square. So yeah, it's correct. So this type of problem, you try some more other problems you can try at home. I hope this particular lecture on Laplace transformation benefits you. So thank you for watching till now, and kindly share with your friends.